In this part, we will do more law of sines. Other than using the law of sine to find the rest of the measurements, I also want you to tell me whether the given information results in one triangle, two triangles, or no triangles at all. So let's take a look at the first one. So we have A, B, and then angle A. So what is the first thing that we have to do? Do we just jump straight to the math? Nope. We need a triangle. I need to see, I need some visuals. So let's draw a triangle. So we have number one, let's draw not a right triangle, let's draw a triangle. It doesn't have to be perfect. And then A, B, C, so they go from left to right, right? So A, this is a 50 degree, don't know B yet, don't know C yet. And then on the opposite side of A, we know that small a is equals to 3, small b is equals to 2, no C yet. All right. So do we know a full pair? Yup, we know a full pair for A. So we have sine of A, 50 degree divided by 3 equals to, let's find B. Sine of B degree divided by small b, and then we do cross multiply. So 2 times sine of 50 equals to 3 times sine of b. And then we divide both sides by 3. So 2 times sine of 50 degree divided by 3 equals to sine of b. Ooh, how do you solve for b? To solve for b, you have to take inverse sine on both sides. We remember this. We have sine of pi over 6 equals to 1/2, right? And then sine inverse sine of 1/2, you go back to pi over 6. Remember that? So we are going to discuss this one more time later in this problem. So b is equals to inverse sine of 2 times sine 50 degree divided by 3. And then what is b equal to? So speaking of evaluating a sine, the mode must be in degree mode. So in case you didn't watch the previous part, you hit the mode key. The mode key. There is a mode key in your calculator. So you hit the mode key and then make sure the angle. So in my calculator, it's line 3. Make sure the angle is in degree. All right. So it's in degree. Mine is in degree. So if yours is in radian, you have to put that in degree. All right. So once you're done, you click second mode to quit. All right, we have inverse sine. So second sine, to get the inverse sine, you have 2 inside the parenthesis. We are going to do the job. So sine of 50 degree, close parenthesis. Remember, you have to close parenthesis. If you don't, they will do 50 divided by 3, which is a terrible mistake. Again, close parenthesis. All right, divided by 3. Did you close your parenthesis? Yes, right? Enter. So you have 30.7 degree. For the degree measurement, I will keep 1 decimal place. So 30.7 degree. All right, so now we got B. I can go ahead and find C, right? So C is the total of 3 interior angles that equals to 180 degree minus 50, right? So A and then minus B, 30.7. So that is equals to 99.3 degrees. So now I got B, I got C. I need to find the small c. So let's use the c we just found. So we have sine of c divided by small c equals to sine of, let's use a 50 degree divided by 3. And then you do the cross multiplication. So 3 times sine of 99.3 degree equals to c times sine of 50 degree. So what is c equal to? C is equals to 3 times sine of 99.3 degree divided by sine of 50 degree. So c is approximately equal to what? Just do it. 3 times sine of 99.3. What's next? Divide? Nope. Close parenthesis. Divided by sine of 50 degree. That is equal to 3.86. So that is around 3.86. Now I just got all the measurements. Are we done? The answer is no, we are not. Now, I need to explain something extremely important. So let's switch colors for that. Let's switch to red. Now, the question is the inverse sine of 1/2. I am stepping off the problem for now. I will go back to the problem in a minute. This has two answers. All right, has two answers. So what are those two answers? Let's start with sine. So sine of pi over 6. What is that equal to? Sine of pi over 6. Take a look at the unit circle. So sine pi over 6 is right here, right? So we have what? We have y coordinate that equals to 1/2. So that means inverse sine of 1/2 is equals to pi over 6. So when you evaluate inverse sine of 1/2, you are looking at all the y coordinate, right? You are looking at for the positive y coordinate. So pi over 6 gives you a positive y equals to half. Also, the 5 pi over 6 gives you the same y. So that means inverse sine of 1/2 gives you 5 pi over 6 too. So this is a pi over 6, also 5 pi over 6. Why is that so important? Okay, so let's draw the unit circle. We are not going to sketch the entire circle. This is pi over 6, right? So that is pi over 6. Where is 5 pi over 6? 5 pi over 6 is right here. So this one is from the initial to the terminal. So this one is 5 pi over 6. 5 pi over 6 is 150 degrees. So that means there is another pi over 6 in there. So to get to the 5 pi over 6, we know that a 5 pi over 6 plus pi over 6 equals to 6 pi over 6, which is equals to pi, right? That is 180 degrees. Meaning that if you take 180 degrees, you subtract pi over 6, then you get to the 5 pi over 6. So now we are stepping back to the problem. So the problem is for angle measurement B, we have a B is equals to inverse sine of 2 times sine of 50 degrees divided by 3. That is equals to 30.7, right? So this is around pi over 6 of 30 degrees. All right, what is the other answer? Other than 30.7, I should have another answer that is similar to 150 degrees right here, right? How do you find the other answer? So the other answer is you take 180 degrees, which is pi, and then you minus the pi over 6. Look right here, minus the yellow. Minus, it's not completely pi over 6, is 30.7. So 30.7, we have 149.3. What is 149.3? 149.3 is another possible measurement for angle B. I said another possible measurement. Is this possible? Tell me, is this possible? Is this a possible answer? If based on the theory, yes, there is 149.3. But if you put this degree into our oblique triangle, is that possible? What do we have? So given that we have A equals to 50 degrees, right? So right here. So if B equals to 149.3, is this possible? Let's find out. So what is the sum of the three interior angles? 180, right? So we have take the 50 degrees plus 149.3. I haven't counted C yet. So this one is already more than 180 degrees. There is no room to fit angle C. So that means this is not possible. So this angle B right here is not possible. Because if you fit this into the triangle, the sum of A and B is already more than 180 degrees. So there is no room to fit C, right? So if C equals to some degree, like 1 degree, we already go exceed 180 degrees. So the shapes that we have is no longer a triangle, right? So that tells me in this problem, there is only one possible triangle. So one possible triangle. And then other than the given conditions, we have angle B around 30.7 degrees, only possible answer. Angle C around 99.3 degrees, and then the small c equals to 3.86. And then all the other measurements, they are in the givens. So there is only one possible oblique triangle. All right. So let's take a look at the next example. The next example has two possible answers. Time to change colors for that. So the next one, we are not going to go back. I will just copy the problem for you. So number 2, we have b equals to 4, small c equals to 6, and then big B equals to 20 degrees. And then first, we don't jump straight to the math. We draw a oblique triangle. All right, again, it doesn't have to be perfect. So A, we don't know. B is 20 degrees. C, we don't know. So on the opposite side of B, we have B equals to 4. So B is equals to 4. Opposite side of angle C, we have C equals to 6. Opposite of A, we don't know what the small a is. All right, so that means when you set up the equation, you cannot bring the a in. Because if you bring the a in, we have two unknowns in one equation. That makes the equation not solvable. So what we are doing now is we want to bring the b in. So sine of b, 20 degrees, divided by small b is equal to sine of c divided by small c, which is 6. So we solve this cross multiplication. 6 times sine of 20 degrees equals to 4 times sine c. So we have c. I will just put the c. To be honest, I don't like keep writing the degree symbol. So we have 6 times sine of 20 degrees divided by 4 equals to sine of big C. All right, and then you solve for C. So C is the inverse sine of everything on the left side. So 6 times sine of 20 degrees divided by 4. And then we go to our calculator. Second sine, we get the inverse sine. 6 times sine of 20 degrees, close parenthesis. If you don't close parenthesis, you are not having 20 degrees. You have 20 degrees divided by 4 first, which is completely wrong. So you get the multiplication done and then divided by 4. We do this in one click so that we can we can minimize the round off error. So that is equals to 30.9. So C is around 30.9 degrees. All right. And then other than that, we can easily find A, right? So how do you find A? C is 30.9. So we take 130 degrees minus C, 30.9. What is that equal to, by the way? That is equal to 149.1. All right. But if you take a look, so we have 180, the sum, minus a big C, that is equals to 140.9, which is the sum of A plus B, right? What do we have for B? So for B, we have a 20. So if you take the 100, if we take actually let's start right here. I'm going to go ahead to do the rest first. And so we have 30.9. So we are going to look for A. So A is equals to 180 minus 20 minus 30.9. That is equals to 129.1 degrees. I just got my A. All right. So now I'm going to use the big A to solve to find the small a. So we have sine of 129.1 degrees divided by A. So that is equal to sine of B divided by B. And then we cross multiply. So 4 times sine of 129.1 degrees equals to A times sine of 20 degrees. And then we solve for A. So A is equals to 4 times sine of 129.1 degrees divided by sine of 20 degrees. So this one A is around, let's find out, 4 times sine of 129.1 degree, close parent. I'm doing this right? 4 times sine of that divided by sine of 20. So that is 9.08. So that is the measurement for A. So now we got everything. We got C, we got big A, we got small a. So we go back to C equals to 30.9 degree. So I just said that 180 minus C is equals to A plus B, but the logic is wrong. So allow me to fix this. I'm going to correct this right now. So this one, we remember that we have pi over 6 and 5 pi over 6. Inverse sine of 1/2 has two answers, right? So this time we have 30.9 degrees. So 30.9 degree is something close to pi over 6, right? And then how do you find the 5 pi over 6? So all you have to do is you take 180 degree minus 5 pi over 6, then you get to pi over 6. This 180 minus 30.9 is not equal to the sum of A plus B. I take 180 minus 30.9 to get the other possible answers of angle C. So this is equals to 149.1. So that is a possible answers for angle C. But is this possible? Let's find out. So I just said that this is angle C, right? What else do we know? So back to the triangle, we have angle B equals to 20. So we take 149.1. I said this is a possible answer for C. So we add a 20 to it. So this is 169.1. So that is less than 180 degree. So there are two possible triangles. So that tells me there are two possible triangles. Where is the other possible triangle? So we are using C. So this is a angle measurement for C. So we have sine of actually let's find A first. Don't worry about the sign. So A is equals to 180 degree minus 20, that is B, and then you subtract C, 149.1, that is equals to 10.9. So now I just got my angle measurement for A, and then you apply the law of sine. So we have sine of A divided by sine A, we don't know sine A, and then sine of 20 divided by 4. You cross multiply. So we have 4 times sine of 10.9 equals to A times sine of 20 degree. And then A is equals to 4 times sine of 10.9 degree divided by sine of 20 degree. Okay, so overall, what do we have? We have a 4 times sine 10.9 degree divided by sine of 20 degree. So we have 2.21 equals to A. So other than 9.08, A can also be 2.21. When A is 2.21, then the angle measurement of A is 10.9. The angle measurement of C is 149.1. So this is the end of this problem. We have A equals to A, C equals to 3, and then big C is 125 degree. We draw a triangle first. Again, it doesn't have to be perfect. We have A, B, and then 125 degree. So A, on the opposite of A, we have A, opposite of C, we have 3, and then B, we don't know. All right, so since we know the full pair for C, let's use C. So we have sine of C divided by sine C equals to sine A divided by 8. And then we cross multiply. 8 times sine of 125 degree equals to C times sine of A. Oh, actually C is equals to 3. You don't put a 3 in there. C is equals to 3. And then we have 8 sine 125 degree divided by 3 equals to sine of A. And then we have A equals to inverse sine of 8 times sine 125 degree divided by 3. And then this one has no answer. Let's go take a look. So inverse sine of 8 times sine of 125 degree close parenthesis divided by 3. So this one is an error. So this one has no solution. So A has no solution. Why? Why is this the case? So this is no solution because if you just try 8 times sine of 125 degree divided by 3, this is around 2.18. 2.18 is greater than 1. So you have that. That's why this is out of the range. Of sine. Remember what the graph of sine is? So the graph of sine, you have this, right? So the curve is oscillating between 1 and -1. So this 2.18 is like right here. 2.18 is like right here. So that is out of the range of the sine. So that's why it is impossible to evaluate this. Okay, and we remember this. So we have inverse sine of 1/2 equals to pi over 6 and 5 pi over 6. This is possible because 1/2 y equals to 1/2 is equals to why is this y equals to 1/2? Because when you take sine of pi over 6, you take the y coordinate. This is a y coordinate of pi over 6, right? So 1/2 is right here. That is in the range of sine, so that's why this is defined. So since 2.81 is outside the range, then this is undefined. So since it is impossible to find A, then there is no such triangle. Alright, so that will be all in this part. I will see you in the next part. In the next part, we will do application problems.